Welcome to a lesson with Dr. Powell. Let's take a look at a way that we can compute the cosine of pi fifths. Exactly. Okay, we're going to use an idea that the cosine of 3 pi fifths, which is right here at 6 pi tenths, is going to be the negative. So the x value right here is going to be the negative of what it is at 2 pi fifths. That's because 4 pi tenths and 6 pi tenths are both pi tenths away from this line right here. So it's symmetric about right here. So the cosines would just be the negatives of each other. Now we use identities here and here to get expressions in cosine of pi fifths to get a polynomial that cosine of pi fifths satisfies. So first of all, this is a double 2 times the angle we're interested in. We can use this idea from the sum formula. You could even think cosine squared minus sine squared, which using a 1 minus sine squared and a negative boils down to this identity. So we're going to use this identity on the on this side, and the negative of that would be this. If you let x be equal to cosine of pi fifths, then really we're well on our way. This equation right here really has a negative 2x squared plus 1 coming from it. So most of our work right here on this right here in the slide will be devoted to this side of the equation here, getting 4x cubed minus 3x. How is that obtained? That comes from cosine of 3 theta. So we can use the sum formula for cosine, which is basically, think of this as being theta plus 2 theta. So you have a theta and a 2 theta, theta and a 2 theta with the cosines and the sines and a minus. That's kind of the sum formula for cosine. So looking at that, we have cosine theta, cosine 2 theta, minus sine theta, sine 2 theta. Now we can reuse this guy right here, and we have everything over here in terms of cosines. Now what about over here? If we use an identity for sine 2 theta as 2 sine theta cosine theta, so we can rewrite this as 2 sine squared times cosine theta, then sine squared is like 1 minus cosine squared. All of a sudden we have everything in terms of cosines. So, and combining like terms, we end up getting this, and which is what we wanted, which is 4x cubed minus 3x is equal to this. And we can put it all on one side. We have a polynomial set equal to 0. Now we know that x equals cosine of pi fifths is a root of that polynomial. Okay, now we know that this satisfies this polynomial equation, which we rewrote it so that we're in decreasing powers here. And upon inspection, you might note that x equals -1 is a root. If you plug in -1, it makes this polynomial 0. And if we do in synthetic division, which is this polynomial division here, we find a quotient, which is this, which represents 4x squared minus 2x minus 1. So we actually get a factorization, x plus 1, since x equals -1 is a root. And that was from the divisor over here. So we just factored our polynomial using synthetic division. And so we get this. And we know that, well, the only root of this is -1. So the cosine of pi fifths is not -1. So it's a root of this guy over here. Now let's solve this. We can complete the square perhaps. And in doing so we can divide everything by 4, get this line. Now we can replace this with x minus just 1/2 of that, so -1/4. But then you subtract off the square of 1/4, which is 1/16, and then you can add that. And then if you add over 1/16, that's actually 5/16. Take a square root of that, it's square root of 5/4, but plus or minus, and then you're kind of adding the 1/4 over. So you get this. Now, which one do we pick, plus or minus? Well, if minus, well, square root of 5 is bigger than 1, so minus would give you a negative result. But cosine of pi fifths is positive on where it's located in the first quadrant. Therefore, this right here, 1 plus square root of 5/4 is cosine of pi fifths. It's kind of nice, especially for like a pentagon, where this angle actually comes out, pi fifths or even 2 pi fifths or other things like that. So if we're making computations within a pentagon itself, this is actually kind of a nice number to use. Right here, 1 plus square root of 5/4 is equal to the cosine of pi fifths. Thanks for watching.